Hello, welcome to the video. Uh, we're going to be looking at section 9.6, where we're going to be solving non-linear systems of equations. So something that's a linear equation or a linear system, we talked about in previous math classes. Um, it's where you have two essentially lines and they intersect at a single point. So if I had like my coordinate here and I had a line going like this and I had my equation of my line going like this, there's the intersection. The intersection is the solution to the system, right? It's where they both cross. Now, we're looking at nonlinear, so we are going to be concentrating on a system where you have a quadratic, so like a parabola, and it crosses a line like so. So there's the possibility of having two solutions like we have here. We have the possibility of having like one solution, like right there. So this is my line. That's my parabola. Or we have this situation where you could have a parabola and a line and where they don't cross. So this is two solutions, two coordinates, one solution, one coordinate, and zero solutions. All right. So there are different ways that we can go about solving this. Uh, One of them is graphing, but we're not going to concentrate on graphing this. We're going to concentrate on the two different scenarios where you're looking at substitution and elimination. So if we were to look at the substitution method for solving this system, what we have is we have y's set by themselves. So what we're going to do is we're just going to replace y's with these values of either x squared plus x minus 1 or negative 2x plus 3. And you're going to set, since they are already equal to y, we're going to set them equal to each other. So what we're going to do is this is going to be negative 2x plus 3 is equal to x squared plus x minus 1. All right, so like this right here is y in the first equation. Well, y also equals negative 2x plus 3. So that's why we can substitute that. All right, so because we have this quadratic here, we need to set our equation equal to 0 in order to solve. So that means I'm going to add 2x and subtract 3, add 2x and subtract 3. So now I got 0 equals x squared plus 3x minus 4. Okay, so I'm hoping I can factor this. If I can't, I probably have to use the quadratic formula. So let's see if we can factor it. So we go parentheses, parentheses, this is x, different signs, larger numbers attached to the plus. Are there two values that give me a product of 4, but their difference is 3? Thankfully there is. 4 and 1. 4 times 1 is 4, but 4 minus 1 is 3. So zero product property tells me that x equals a negative 4 and x equals a positive 1. So in this situation, we're going to have two coordinates as our system. So what we're going to do now is I am going to choose one of these equations to solve for y. I'm going to use this one. It's the easiest one to solve for because there's only one variable I have to substitute. So now I'm going to have y equals negative 2 times it by a negative 4 plus 3. So negative 2 times it by negative 4 is 8. So this is going to be 8 plus 3, which is 11. So my first solution is negative 4 comma 11. The second one over here, I put 1 in, so I got y equals negative 2 times by 1 plus 3. This is going to be negative 2 plus 3. So that equals 1. So my other solution is 1 comma 1. So this is a situation where it had two coordinates, two different solutions where they intersected. For this particular one, they are asking us to use the elimination method. All right, so what you have to do in order to solve it using the elimination method is you need at least two variables that have the same coefficients, or at least we can get the same coefficients. All right, if you notice here we have um, y and y, their coefficients are both 1. And we have x here and x here have the same coefficients of negative 3. So what we're going to do is I'm going to set up this first equation, equation 1, as y equals x squared minus 3x minus 2. And then what I'm going to do with the second equation, I'm going to go y equals, and then I'm going to place the negative 3x right underneath to keep all of my variables the same. Okay, so what I want to do is I want to be able to eliminate those two that I said I had in common, y's and the negative 3x. In order to do that, I need to multiply this bottom equation, or you could have done the top, but I'm just going to choose the bottom one, by negative 1. So y equals x squared minus 3x minus 2 remains the same. On the bottom, it's negative y is equal to positive 3x plus 8. I just changed the signs. What that does is this then cancels because y minus y turns to 0. There's nothing I can combine with the x squared, so I leave this x squared here. This also gets crossed out to be 0, but since there's other stuff on the right-hand side of the equal sign, I don't have to write in 0. And then I have negative 2 plus 8, which is plus 6. All right. So what I have is I have a situation where, in the grand scheme of things, ax squared plus bx plus c, b is 0. So since b is 0, I can solve this using the square root. So I can subtract 6 from both sides. I get negative 6 equals x squared. I take the square root of both sides. But if I take the square root of that negative number, I get no solution. So this is a scenario where this is no solution, which means that, yeah, I have two graphs, but they don't intersect. They could intersect. So they maybe look something like this. Or like, oh, I have this parabola here and this line goes here, and they don't touch. So again, looking at these, let's do number 9. Let's do number 9. Let's see if I can solve this one. They want us to eliminate. Okay, let's see here. Actually, number 9 is another no solution. Let's get one that is a solution for elimination. So let's try 8. So let's look at this one. So here I only just have the 1, which is y, which can happen, So on the top, I'm going to have y equals 9x squared plus 8x minus 6. And I'm going to change the sign of this one here so it becomes negative y is equal to negative 5x plus 4. So this becomes 0, and then this becomes 9x squared minus 3x minus 2. Okay, so can I factor this? The answer is I'm not sure quite yet, but usually what I like to do is if I'm not sure and all I got to find is my value or values for x, I'm just going to automatically resort to the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Why not? If they're not asking us to factor it out completely, but I'm looking for is the values for x. Let's do it that way. So opposite of b is 3 plus or minus the square root of uh, negative 3 squared is 9 minus 4 times a, which is 9, and b, which is negative c, which is negative 2, sorry. And it's all divided by 2a, which is 2 times 9, which is going to be 18. All right, so now taking care of what's inside the square root, I'm going to multiply negative 4 times 9 times it by negative 2, which I get, so 3 plus or minus the square root of 9 plus 72 all divided by 18. 9 plus 72 is 81. Square root of 81 is 9. So I have 3 plus or minus 9 all divided by 18. So my two answers, I get 3 plus 9, which is 12. 12 divided by 18 gets reduced to um, 2/3. Oh, so this would be plus, and then this would make this minus, this would be minus, I'm sorry, this would be negative 2/3. So negative 2/3. And then negative 3, hold on, I screwed that up. Negative 3 plus 9, which would be 6. 6 divided by 18, which would be 1/3. I'm sorry. My apologies. This would be 1/3. That's what happens when you miss a negative somewhere. My apologies. So this would be positive 1/3. Then negative 3 minus 9, which would be negative 12, divide that by 18. That's negative 2/3. So these are what my values with x would be. To find y for those, I'm going to pick like the second equation here because there's less variables I have to take care of. So y equals 5x minus 4. So y equals 5x. So I'm just going to say 1/3. And I said minus 4. Is that what I said? Yep. So this is going to be what? 5/3 minus 4. This will be what? Y is negative 7/3 when you all add it up. So my first solution is 1/3 comma negative 7/3. And if I go y equals 5 times negative 2/3 minus 4, so I have 5 times negative 2/3, and I subtract that by 4, I am going to get an answer of negative 22/3. So my other end is going to be negative 2/3 comma negative 22/3. And that is being able to solve nonlinear systems of equations. Hope this helps. Until next time.